A hyperbola is formed by cutting two cones of similar diameter and height. So if you introduce a cutting plane here that is perpendicular to the base, so what will form is a shape like this, and this shape is called a hyperbola. So the hyperbola has the following components. So this is your transverse axis, so the transverse axis contains the following. So we have your vertices V1, V2. This is the center of the hyperbola, and these are the foci. So you have here F1 and F2. Now, the distance from the center to the vertex is your distance A. The distance from vertex to vertex is 2A, while the distance from the center to the focus is your distance C, as well as this distance. This is your distance C. Now, this axis perpendicular to the transverse axis is called the conjugate axis, while this rectangle is called the auxiliary rectangle. The auxiliary rectangle connects the line, this line, broken line here, to here. Then it intersects the center of the hyperbola. So this distance is your distance B. So this is parallel to the transverse axis. So this distance, then these lines are the asymptote lines. So we have your L1 and L2. So your L1 is the equation of y is equal to negative b over a x, while this line L2 has the equation of y equals b over a x. So your hyperbola can be located at with center at the origin or center at point HK, and the orientation could either be horizontal or vertical with respect to the transverse axis. So your standard equation for the hyperbola with center at the origin, when you have vertical transverse axis is y squared over a squared minus x squared over b squared equals 1. When your center is at hk, we have y minus k squared over a squared minus x squared x minus h squared over b squared equals 1. If your transverse axis is at horizontal position, you have x squared over a squared minus y squared over b squared equals 1. If your center is at hk, you have x minus h squared over a squared minus y minus k squared over b squared equals 1. So this one we can easily identify if your hyperbola is horizontal or vertical by looking at the y or x element. So if you notice here, if your y squared and x squared has opposite signs, if your y squared is positive and the x squared is negative, it is automatically identified as a vertical hyperbola with respect to the transverse axis. Meaning to say, your vertex and vertices and foci are in vertical position. Now, if the x squared element is having positive sign and the y squared is negative, it is considered as horizontal position. So let us solve an example. So these are the standard forms of equation, while the general form can either be ax squared minus bx squared plus cx plus dy plus e equals 0, or but this is by, or we have by squared minus ax squared plus cx plus dy plus e equals 0. Now let's solve an example. So if we have an equation for x squared minus 5y squared plus 32x plus 30y equals 1. Now we have to determine V1, V2, F1, F2, center, and sketch the graph. Now, this is in general form. So in order to determine those elements, let's transform this to standard form. So let's copy 4x minus 5y squared plus 32x plus 30y equals 1. Now let's group the terms with x and the terms with y. So let's write it like this: 4x squared plus 32x minus 5y squared plus 30y equals 1. Now let's complete the square in order to transform this into a standard equation. So first let's factor out 4. So 4 times x squared plus, so 32 over 4 is 8x. And then by completing the square, we add the square of 1/2 of 8. 1/2 of 8 is 4, the square is 16. Minus 5 multiplied by, so let's factor out 5. Y squared minus 6y plus, so the square of 1/2 of 6, so we have 9 equals 1 plus 4 times 16 minus 5 times 9. So what we added here on the left side shall be added on the right side of the equation too. So by simplifying the equation, we have 4 times x plus 4 squared minus 5 times y minus 3 squared equals, so we have here 64 plus 1 is 65 minus 45, 20. So let's reduce this 20 to 1 by dividing the whole equation by 20. So we'll generate x plus 4 squared over 5 minus 5 or y minus 3 squared over 4 equals 1. Now we have center with the coordinates of -4, 3. The value of a squared is equal to 5. Therefore, a equals square root of 5 or 2.2. Now, your b is 4. So, our b squared is 4. b is a square root of 4 or 2. Now, we have c squared equals a squared plus b squared. So, c is equal to the square root of 5 plus 4. c is equal to 3. Now, we have the center, the value of a, b, and c. We can draw the graph. So, based on the equation, it is the x variable that is positive. Therefore, the orientation of the parabola is horizontal with respect to the transverse axis. So we have center at -4, 3. So your graph will look like this. So this is your x axis, y axis. So we have center at -4, 3, 1, 2, 3, 4. So this is negative 4. 1, 2, 3. Or this one, 1. So this is negative 3. This is 1, 1, 2, 3. So your center is located here. Now, we locate the vertex. So your C is negative 4, 3. Now let's locate the vertex. So the vertex is 2.2 units away from the center. So going to the right. So this is negative 2, 10.2. So we have the center here, or the vertex 1. So your V1 has coordinate of negative 1.8 and 3. Now, let's move 2.2 units to the left. So we have here, so negative 4, negative 5, negative 6. So your second vertex has coordinate of negative 6.23. So this makes your transverse axis. Now, B is 2, so let's move 2 units here. So your B is somewhere here and somewhere here. So this is 5. Now we can create the auxiliary rectangle. So C is 3. This is your focus. So your F1. We have negative 7, 3 and F2 here of negative 1, 3. Connecting the lines. So these are your asymptote lines here and here. And your graph would look like this. Now, to solve for L1 and L2 asymptotes, just equate this equation to 0. So x plus 4 squared over 5 minus y minus 3 squared over 4 equals 0. Then get the value of y, and you will be able to get for the equations of L1 and L2.